Okay, so the other day we went over some of the key features and some things about polygons. Okay, remember, a polygon is a shape that has straight sides, okay, and it's closed, all right? So it's not going to have a curve and it's not going to have an opening, okay? It has like a middle area, so for example, this one's not a polygon. If I separated this, it would be two different polygons, but together it's not one because it isn't open in the middle. Does that make sense? Okay, we learned about convex and concave, the difference between the two. So remember, convex was without dents, concave was having a dent, so where one of the sides like goes in, okay? And then we also learned about equilateral and equiangular, the meaning of those things. And that if a polygon is regular, in order to be regular, it must be equilateral and equiangular. So all sides congruent, all angles congruent in order to be regular, okay? So today we're going to be learning about the measurements of the interior and exterior angles and how that relates to the number of sides in a polygon, okay? So we're going to be filling out this lower portion of the note sheet today, okay? So we're going to start with a triangle, okay? You guys have learned about triangles before. We did a whole unit on triangles. Triangles have how many sides?
3.
And you guys know that the sum of their interior angles is how much?
180.
180. This is something you guys have learned already, okay? Now, if we have a triangle and it is regular, which means all the angles are the same, then I can just divide 180 by there are 3 angles to find the interior angle. So 180 divided by 3 would give me what? 60, and that would give me the interior angle of the triangle. Now, if I take a side of the triangle and I extend it, it creates this exterior angle. Remember, exterior means outside, right? So this is an exterior angle right here, an outside angle. And I can find the measurement of the outside angle because if I know the inside one, the inside plus the outside makes a linear pair. It makes a straight line. What's the measurement of a straight line? 180. So this one plus this one has to add up to 180. So what does this outside one have to be? 120, okay? So I know that the exterior one I can find by just using that those two angles are supplementary, okay? All right, so now let's talk about this quadrilateral that we have here. Okay, you guys learned that quadrilaterals have 4 sides. You also learned what do all the angles inside the quadrilateral add up to? What do they add up to? 360, okay? So we get 360 degrees for our sum. And now if this was a regular quadrilateral, I could divide this number by 4 because there's 4 angles. And I get that all of these angles are 90 degrees, okay? Now, what's the measure of the exterior angle here? Yeah, also 90 because 90 plus 90 makes how much? 180, right? Okay, so now we're going to get into some polygons that have more than 3 or 4 sides, okay? This one has 5 sides, a 5-sided polygon. Does anyone know the name of that? Pentagon. Good. Okay, a pentagon has 5 sides. Its sum of its interior angles adds up to 540. And if I take this number and I divide it by 5, that gives me one of the interior angles in a regular pentagon. So when I divide it by 5, that actually gives me 108. Okay. Now, when I subtract 108 with 180, what do I get for the outside or the exterior angle? 72. Okay. All right. Anyone know what a 6-sided shape is called? hexagon. Okay, and a hexagon has an interior angle sum of 720 degrees. Okay, each interior angle is taking this and dividing it by 6 because there are 6 sides. So 720 divided by 6 gives me 120 degrees for the interior angle. And then what's the exterior going to be? 60, right? Because those two then add up to 180. Okay, now, I want you to look at the sums of the interior angles. As I get more and more sides, what happens to the sum? Okay, it gets bigger and bigger. And what's it going up by each time? Yeah, add 180, I get 360. Add 180, I get 540. Add 180, I get 720. So add 180, what am I going to get here? 900. Okay. Now, this figure has 7 sides. You guys know what a 7-sided shape is called? You are close. Heptagon. Heptagon. Okay? With an H. Don't know. Okay. That's a good research question. Who named the heptagon? A heptagon. Good question. Okay. All right. So, how much is each interior angle? Well, when we divide this one by 7, watch what happens. We get 128.5714286, and it keeps going. There's more numbers after that, okay? So, we're just going to round this to the 10th place. It's about 128.6, about, okay? It's not exact, but it's about that. All right? And we're just going to use an estimated measurement for the exterior angle as well. So when I subtract this one with 180, I get about 51.4. Okay? All right, so what's an 8-sided figure called? Yeah, octagon. Maybe some of you watch UFC, you see they fight in the octagon. It's because the ring has 8 sides. Okay, so there's your angle sum measure, 1,080 degrees. If I take it and divide it by 8, we end up getting 135. And then what's the exterior angle? 45. Okay. All right, so what about a shape with 9 sides? Yeah, it is. It's called a nonagon. Good guess. All right. Okay, that one, let's add 180 degrees to this, and we end up getting 1260. Okay, and so then we divide that number by 9, and we get 140. And we subtract this number with 180, and what do we get? 40. Okay. Now look, are you guys noticing that as it gets more and more sides, the interior angle is increasing? The size is getting bigger and bigger. What's happening to the exterior angle? Smaller and smaller and smaller. As that interior angle gets bigger and bigger and bigger, the exterior angle starts to get smaller and smaller and smaller, right? Okay. All right, so for 10 sides, do you guys know what a 10-sided figure is? Decagon. Okay. And that interior angle sum is going to be 1,440 degrees. Okay, the interior angle is going to be what? 144? Okay, and then the outside? 36. Okay, now, after that, like, like other shapes with other sides, like say you had a polygon with 17 sides, okay, there's no like special name. They just call it like 17-gon. Has 25 sides, it's a 25-gon. Has like 78 sides, it's a 78-gon. There's not special names for all those other different ones. Does that make sense? Okay. So, like, these are the only ones that are kind of important that you guys actually know what the names are and how many sides that they have. Does that make sense? There's actually one called a dodecagon. That's 12 sides. Okay? But I'm not so worried about that. I'm just more worried about you guys know like the names of these ones up to 10 sides. Okay? All right. Now, so say, for example, I give you a problem and I say, what's the sum of the interior angles of a 25-gon? Like, do you really want to sit here and do like this one plus 180 plus 180 plus 180 plus 180 plus 180? Like, do we really want to do that over and over again till we get to 25 sides? Not really, right? So there's actually a formula that we can use, like a shortcut, so we don't have to keep adding 180 over and over again, okay? So this shortcut is for the sum of the interior angles. You need to memorize the formula for the shortcut, okay? It's something you should have memorized. And you should know that it only works for what we call convex polygons. So I want you to write underneath here, convex. All right? So remember, what is a convex polygon? Without dents, okay? No dents. So this formula doesn't work for polygons that have dents, okay? But it works for all the ones without dents, okay? And it will work for a regular one or an irregular one. So, like, a lot of times you guys are used to seeing these perfect ones, right? But, like, I could have a pentagon where it's not regular. Like, look at this. This has 1, 2, 3, 4, 5 sides, right? It's not a regular pentagon, but it's still a pentagon. Is it concave or is it convex? Convex, there's no dents in it, so this formula will still work for this shape. Now, these formulas that we're going to go over in a minute for the interior and exterior angles are not going to work. But the sum formula will work for any convex polygon, okay? All right, so here is what the formula says. The formula says I take 180 degrees and multiply it by n minus 2. Now, what does n represent? N always represents the number of sides in the polygon, okay? So in all these formulas, n is representing the number of sides, okay? So let's see if it holds true for some of the shapes that we've already done. So for triangle, the sum was 180, right? Let's try it out. How many sides are in a triangle? 3. What's 3 minus 2? 1. What's 1 times 180? Did it work? Okay, let's try it out for quadrilateral. How many sides are in a quadrilateral? What's 4 minus 2? What's 2 times 180? So did it work there? Yeah. Okay. What about for pentagon? How many sides are in a pentagon? What's 5 minus 2? 3. What's 3 times 180? 540. So do you guys believe me? Do you think it's going to keep working for all these other ones? Yeah. Okay. Now, the cool thing about this formula is that, like I said earlier, it's a short way of finding the sum, okay? Especially shorter when we have lots of sides in our figure, okay? So we don't have to keep adding 180 over and over and over and over again. Does that make sense? Okay, so let's say, for example, I asked you guys, what's the sum of the interior angles of a, I don't know, a 22-gon? Well, how many sides does a 22-gon have? 22. So you would do 22 minus 2, right? And that would give you 20, and then you multiply 20 by 180. And you get 3,600. And that would be the answer for the sum of the angles, okay? So that's a lot faster than doing like 180 plus 180 plus 180 plus 180. Does that make sense? Okay. Now, there's also a formula for finding each interior angle of a regular polygon. Now remember, what does regular mean? All the angles and all the sides are all the same. They're all equal, right? So this formula for the interior angle, it only works when all the angles are the same size, okay? So the formula is take the sum. So we know how to find the sum. This is how you find the sum, right? So take the sum of all the angles and then divide it by what? Well, did we divide all of these by 2 to get this number? What did we divide this sum by to get that? By the number of sides. So we're going to divide it by n. Okay, so that's the formula. Okay, the formula is the sum divided by the number of sides. Okay, so we'll just try it out with just a couple, just to illustrate that it works, okay? So let's try it for a triangle. For a triangle, 3 minus 2 is 1. 1 times 180 is 180. Now, I'm going to divide it by the number of sides, so 180 divided by how many sides in a triangle? 3, so what's 180 divided by 3? 60, right? If I try it for quadrilateral, 4 minus 2, 2. 2 times 180, 360. 360 divided by how many sides in a quadrilateral? 4 gives me 90, right? So is this going to keep working for all of them? Okay. Now, I'm not going to go through every single one. We can just fill in the numbers we got up above because we already have all these numbers, right? But the cool thing about the formula is, say I ask you, what's the measure of an interior angle in a regular 15-gon? Well, what number are you going to plug into n then? 15, right? What if I ask you for a 27-gon? What number are you going to plug in then? 27. Does that make sense? Okay, so it's a fast way of finding those numbers. Okay, now, the last one that we're going to talk about from these formulas is the exterior angle in a regular polygon. Okay, so that's like the outside angles here. How do we find those outside angles? Okay, well, the process was kind of lengthy, right? We found the sum, then we found the inside angle, and then we subtracted the inside angle from 180, right? I could write all that down into a formula, but it's kind of lengthy and time consuming. There's actually a faster way of doing it, which is this. 360 divided by the number of sides. The reason why this works is how many degrees are in a whole circle? Do you guys know? 360, okay? So all of these exterior angles, if I keep drawing more and more exterior angles off of my shape, if I were to cut them out and put them all together, they'd all wedge together into a bunch of pieces of pie and make a circle. Okay, and so that's why it's 360 degrees are in a circle divided by the number of sides. Okay, so let's give it a test. What's 360 divided by 3? 360 divided by 3? 120. What's 360 divided by 4? What's 360 divided by 5? If I actually divide 360 by 5, I do get 72. What about when I divide it by 6? 60. And 360 divided by 7? Yeah, if I rounded it, I get 51.4 about. And then divided by 8. Okay, and I could keep trying that for some other bigger numbers, right? And I could get the exterior angle, okay? Does that make sense on that one? Okay. So, you guys will notice I kind of skipped over this one up here, right? The diagonals. Okay, I want to talk about that one a little bit. Now, you guys learned about diagonals when we were learning about quadrilaterals, right? And so, when I had like a square, for example, where were the diagonals in the square? Yeah, they were across opposite vertices, right? It was the diagonal basically connects one vertex to the other, and it goes through the center of the shape, right? Or through the inside of the shape. So how many diagonals were in any quadrilateral that we talked about? How many diagonals did it have? 2, right? Now, if a diagonal connects one vertex to the other, and it goes through the inside of the polygon, how many diagonals does a triangle have? If I try to connect this vertex to one of the other ones, can I do it by going through the middle? No. What if I try to connect this one to one of the other ones? Can I do it? No. So does this triangle have any diagonals? No, it has 0, right? Okay. What about a pentagon? Let's take a look at a pentagon. Okay. So if I connect here, I can make a diagonal. But can't I also connect this one over here? Okay. So that's 2 diagonals. I can connect this one here. Can't I connect it also down here? So that's 4 diagonals so far, right? Is there still another place I can connect? How many diagonals? 5. Okay. Now, this shape had 3 sides, no diagonals. 4 sides, 2 diagonals. 5 sides, 5 diagonals. Let's see what happens when I have 6 sides. I'll draw a hexagon. I didn't quite draw it regular, but that doesn't matter. It's okay. All right, so 1, 2, 3, 4, 5, 6. Where else can I connect? Where? Here? 7, 8. Did I forget one? Here? 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 I know there's another one. I'm not seeing it right now. Straight across. 9.
So pretty much each vertices on the polygon has like 2 or 3 connected ones.
Okay, so we get 9 for that one, right? Okay. Is anyone seeing any kind of pattern here?
No, I just have a question.
Okay.
So each vertex has its own like 2 or 3 connecting points from across each other.
But it depends how many other sides there are, right? Because like this one, like the more sides the shape has, the more places it's going to have to connect. Does that make sense? So I want you guys to look at this pattern. How much did the diagonals increase by 2? How much did they increase by here?
3.
And here?
4.
What do you think is going to happen on the next one? Okay. So how many diagonals would you expect the heptagon to have? 14. Okay. So do you guys want to draw it and try it?
Yes, we do.
Okay.
Yes, we do.
Okay. So let's try drawing a 7-sided figure, which is a challenge in itself. 1, 2, 3, 4, 5, 6, 7. Okay, I got 7 sides there. Okay, now let's try connecting. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. This way, this way, this way. There. 14. All right, so did I get it? Okay, we got it, right? Okay, so what would you expect the next one to have? What would I need to add to get to the next one? 6, right? Okay, now, but if I told you guys, well, figure out how many diagonals are in a 30gon. Like, is this plus, 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 like, keep adding? Is that really efficient? No. We want to use a formula, right? Okay, so here's the formula. All right, write this down. N times n minus 3. All of that, whatever you get for that, then gets divided by 2. Okay, so I want you guys to try it with, like, plugging it into the formula, actually. So let's just try it with 3. I'm going to do the inside of the parentheses first. What's 3 minus 3? 0. What's 0 times 3? 0. What's 0 divided by 2? Is that what we got before when we did this? Did it have 0? Yeah. Okay, what about for 4? What's 4 minus 3? 1. What's 1 times 4? What's 4 divided by 2? Is it working out? Okay. So, like, if I continue to do this, the formula seems to be working, right? And it does. It works every time, okay? So, we would end up getting 5, 9, 14. We would get, when we plug in 8, what's 8 minus 3? 5. What's 5 times 8? 40. What's 40 divided by 2? 20. Does that make sense there? Okay. All right. So that's everything for today that we're going to fill out on those notes.